Hello, this is Mr. Ensler, and I'm going to go through the Chapter 12 review in geometry. So, we started off this chapter talking about three-dimensional figures, and three-dimensional figures have faces, vertices, and edges. Now, faces, as we learned in our notes and talked about in class, are the flat sides, so to speak, of the figure. So this is kind of an interesting looking figure right here. It's almost like a cube, except it has this triangle part that's cut out. So a normal cube would have 6 faces, a front and a back, a left and right, a top and a bottom. That's 6. But then we have the 7th one right there. So if we're counting the number of faces, vertices, and edges, this one has 7 faces. Vertices are the points, the corners of the figure. And so when you count these, try to count them in an organized way so you don't lose track. So for instance, I could count like this. 1, 2, 3, 4 along the bottom. 5, 6, 7, 8, 9, 10. So vertices, we have 10. And lastly, edges are the line segments that make up the figure. The edges. So again, I would count those in an organized way. I'll count the bottom 4 first. 1, 2, 3, 4. And then I have these 4 vertical ones. 5, 6, 7, 8. And then along the top, I have 9, 10, 11, 12. And then I have 13, 14, 15 along that corner. Just kind of a weird looking shape there. So 15 edges. Now, we've answered the question and you're done, but one of the things that we learned was called Euler's theorem, and Euler's theorem said that if you add the number of faces plus vertices, it will be 2 more than the number of edges, so it'll equal edges plus 2. And so it's always a good idea whenever you're counting these things to make sure it adds up. So if we say 7 faces plus 10 vertices, does that equal edges? We had 15 plus 2. Well, on the left we get 17, on the right we get 17. Yeah, and that's probably a pretty good indication that you counted it correctly. All right, let's do the next one. Number 2. It's kind of like we have a pyramid, a 4-triangle pyramid, square pyramid on top, and another square pyramid on the bottom. So faces, edges, and vertices. Let's go ahead and count them. So faces, I can see 4 triangle faces on the bottom, 4 on top. And actually the square in the middle, that's not a face since it's not on the surface, it's inside. So there are 8 faces. Vertices, the points, well, we have the bottom and the top, and then we have 1, 2, 3, 4 along the middle. So that's 6. And then lastly, edges, the line segments, so to speak. We have 1, 2, 3, 4 along the bottom, 5, 6, 7, 8 along the middle, 9, 10, 11, 12 along the top. So 12 edges. And if we plug that into Euler's theorem, faces plus vertices, does that equal edges plus 2? 14 and 14, yeah, that works out. So I'm pretty sure that's the answer. All right. The majority of this chapter 12 was all about finding surface area and volume. And we also talked about giving exact and approximate answers. Whenever possible, we're going to try to give the exact answer. If we have to round, we will, but we'll try to give an exact answer first. We'll see if that's always possible. We'll just see how it goes. So remember that you are allowed to use the formulas for these things, and I'll remind you of what those are. Sometimes I'm going to refer to a specific formula, but sometimes I'm just going to talk about how we calculated that surface area or volume because I don't rely on a formula. I just kind of think about it and add up the areas or add up the volume, and so feel free to use the formula sheet, but I don't always use the formula sheet for it. Another thing is, as we go through each problem, make sure you label correctly. Not just the meters and inches and whatever, but surface area versus volume. You want to keep track of what you're doing. All right, so number 3, it's going to help if you know what kind of solid this is. And this is a triangular prism. See how the triangle shape stays constant throughout? If I wanted to, I could cut you pieces of triangle cake. And, I could cut you so many pieces. So, if we're going to find surface area, all we have to do is add up the area of all the faces. And so I have a triangle here, a triangle here, I have a rectangle on front, a rectangle on the right, and then I have a rectangle in the back. And those are all different size rectangles, it looks like. Let's start with the triangle, and I'm going to start with the triangle on bottom. You don't have to resketch it out, but if it helps, you can. This is a 12 by 16 triangle. So the two triangles, let's kind of put them together. It would be 1/2 base times height, and then since we have 2 of them, I'm just going to say times 2. So if you just type all of those in your calculator to figure out the area, it works out to 192. Okay, now let's talk about each of the rectangles. This front rectangle here is 12 by 18. So the front is 12 by 18. See how I'm labeling my work there? It's kind of hard to write on this iPad, so you can write better than I do, but you want to try to keep track of what you're doing so that you can understand it when you look back at it, and so I can understand it when I go to correct it or help you out with it. Here we have another rectangle, and you can see that. You can see that is 16 by 18. So I'm going to call that the right side. The right side is 16 by 18. And so that adds up to 288. And then the only side that I have not taken into account, let me get rid of some of these markings here. The only side I have not taken into account is the back rectangle, that big rectangle back there, right here. I know it's 18 tall, but actually I don't know how wide it is. What I'll have to do is figure out the Pythagorean theorem of this 12 by 16 triangle. So I'm just going to go ahead and do that. 12 squared plus 16 squared will give me this number. I'll call it x squared. If I type that in, 12 squared plus 16 squared, you can just do it all at once, I get 400. And that's convenient because when you take the square root of both sides, it works out evenly to 20. So this is a 20 by 18. So I'm going to call that the back. 20 by 18, which is 360. So we're not going to have to round at all for this surface area. Just add up all of those. Remember that this 192 actually includes both triangles, the top and the bottom. So 192 plus 216 plus 288 plus 360 gives us a surface area of 1,056. So let's label that clearly. Surface area equals 1,056, and that would be square meters. Surface area is how much square units, how many square units would cover it. It's not about what's on the inside, it's actually what's about the outside. Alright. Now, let's switch over and talk about volume. Volume is how much is on the inside. You know, if you were going to fill this with water, if it were a hollow prism and you were going to fill it, how much could you put in there? Or if you were going to fill it with 1x1 blocks, 1x1 cubes, how many cubes could you fit inside here? And so our general formula for all prisms to find the volume is this: the area of the base times the height. So that capital B is area of the base, and then h is height. And by base, we mean the repeated shape. So like I was saying at the beginning of this problem, the triangle is the repeated shape. If I wanted, I could cut you some slices of triangle cake. Now, here's one way to think about it. How many slices could I cut you if I wanted to keep them in whole units? Well, can you see how the height is 18? So that means, if I slice these evenly, I could slice you 18 pieces that would all be exactly the same. So it's like you're going to find the area of the triangle, and then you're going to times it by 18 to figure out how many cubic units it is. Well, actually, I already know the area of the triangle, or I already set that up. 1/2 12 times 16. So let's see here. Volume is going to equal 1/2 12 times 16. Now, I'm not timesing that by 2 because even though there are two triangles, we're just timesing it by the one base. And then that is going to be timesed by 18. So 1/2 times 12 times 16 times 18 is 1,728. And so that is your volume. And that would be cubic meters. So that's a lot of 1 by 1 by 1 cubes. All right, on to the next one. So this is actually a cylinder, would be the name for this figure. And we do just have a formula to use for the surface area of a cylinder. The surface area of a cylinder, so this would be one that I probably would just look up, although we did talk about in class how to calculate this. There's the top circle and the bottom circle, or in this case it's left and right, and so that's just going to be 2 pi r squared, because there are two circles, plus we need to add in the area around the side, that curved part there. Now it's a curved part, but really if you unrolled it, it would be a rectangle. We talked about that in class. So that rectangle is actually going to be the circumference times the height. So 2 pi r, that's circumference, times the height. Now in this case, even though it's not situated the way you might normally think, the height is actually 4. The height is the distance between the two circles. So let's go ahead and fill this in. The surface area is 2 pi 11 squared, because you can see the radius is 11, plus 2 pi 11 times 4. Now this is not going to come out evenly, you can tell, because there's a pi in the formula, but let's calculate everything we can without actually typing in pi. So I'm going to type in 2 times 11 squared, and I get 242. So 242 pi plus, and then over here let's type in 2 times 11 times 4, and I get 88. And that's also pi. I just haven't typed the pi in. Now look at that. Those are actually like terms. If you have 242 pi's and someone gives you 88, how many total do you have? Well, you have 330 pi's. So this is an example of an exact answer. 330 pi square centimeters. And then we will also round that to give an approximate. We've talked about the value of both exact and approximate answers. And rounding to 2 decimals, as it says above, we would get 1,036.73. And that would also be square centimeters. Okay, volume. We actually just have a formula for volume of a cylinder. Volume of a cylinder, it's kind of like a prism actually. It's the area of the base, which is the repeated part. You know, if I wanted to slice for you some pieces of this cylinder cake and keep them all the same, I could slice 4 of them. So each repeated part is a circle. So pi r squared times the height. And that's just the volume formula. So that's going to be pi 11 squared times 4. Again, you know this is not going to come out evenly because there's a pi in there, so I'll just do the 11 squared times 4 at first, which is 484. And so that is timesing by pi, just I'm not typing it in the calculator. So 484 pi cubic centimeters, need a 3 on there. And if you do actually multiply by the pi and round, it's about 1,520.53 cubic centimeters. All right, on to number 5. Number 5, we have a sphere. And this actually goes to the very last lesson that we learned. We have formulas for the surface area and volume of a sphere, and you don't have to memorize them. The surface area for a sphere is 4 pi r squared. So you can see that the 12 is actually pointing at the whole line, so the radius is 6. It's like we have a 6 and a 6. So the surface area is going to be 4 pi 6 squared. I'm just going to type in 4 times 6 squared, and I get 144. So the surface area equals 144 pi square meters. And if you round that, you get 452.39 approximately. Most people find spheres actually very easy to deal with because you just look at the formula and plug it in. The volume of a sphere, we have a formula for that as well. 4/3 pi r to the third. All right, so again, we just put in the radius of 6, and we have 4/3 pi 6 to the third. So I'm going to type this in, but not the pi part of it. That way I can keep it exact. To type in the 4/3, if you're using one of the types of calculators that we use in class, you'd probably want to type it in as 4 ABC, that's the fraction button, 3, and then times 6 to the third. I know we have a squared button, but we don't have a cubed button on these calculators, so the caret button goes to the third. So let me type that in. 4/3 times 6 to the third, and it comes out to 288. So our volume is 288 pi cubic meters. And if you type that in to round it, you get 904.78. Again, make sure you are labeling properly with the correct units, as well as make sure that you are labeling volume versus surface area. We want to know which one you're calculating. All right. Number 6 is a cone. We do just have a surface area and volume formula for a cone. The surface area formula is pi r squared plus pi rl, where L is the slant height. So we talked about this in class. A three-dimensional figure has a true vertical height. That's actually what this 7 is in this case. And then it has a slant height, which is exactly what it sounds like. It's the height if you were to measure it slanted. And sometimes that's given, sometimes that's not. In this case, it's not given. So it's not given, but we are given a right triangle that goes right through the middle. So the slant height is here, but it's also over here. So if you take this right triangle, which we know has a true height of 7 and a bottom part of 3, the slant height is kind of like the hypotenuse of that right triangle. So we'll just set up the Pythagorean theorem. 7 squared plus 3 squared equals L squared. So 7 squared plus 3 squared is 58. And then you take the square root of both sides. And so you can tell this is not going to come out evenly because square root 58 doesn't come out evenly. Let's see if we can simplify 58 as a radical. Let's see here. 58 divides by 2, I know. 2 and 29. Neither of those numbers can divide anymore, except by themselves or 1, which doesn't really count. So actually, the slant height is just going to be radical 58. All right, so let's try and fill this in as exact as we can. The surface area is pi r squared, so pi 3 squared, because the r is the radius of the circle at the bottom of the cone, plus pi rl, pi 3, and then rl is radical 58. We didn't end up doing anything with that 2 and 29. Okay, 3 squared is 9, so 9 pi, and then we usually put the number in front of pi, so I'm going to say 3 pi radical 58. And actually, we can't do anything more to that without rounding. So I guess that would be as exact as we could get. It's not a very practical answer there, but that would be the number of square yards for surface area. So this is one where we would definitely want to give an approximate answer. So if you type that into your calculator, 9 pi plus 3 pi times radical 58, you should get 100.05. That would be the approximate answer. 100.05 square yards. That probably makes a little more practical sense in this case. If you're wondering, why can't I add the 9 pi and the 3 pi here and just simplify it a little more to make 12 pi, it's because this one has a radical 58 and this one doesn't, so they're not like terms. It's almost like if you had 9 pi and 3 pi x. Those wouldn't be like terms because this one has an x and this one doesn't. So we would just have to leave it like that. I believe on the quiz and on the test that you'll take, I word the directions in a way where it says give an exact answer as reasonable. And so I think this would be a case where I would accept if you did both. That's great. You know, I'm always glad if you simplify it and give me both. But in this case, I would definitely understand that this exact answer is not the most practical. And so if you only rounded on this one, because you could tell it's not a very practical exact answer, I wouldn't take any points off for that. So that's part of what you're learning is when is it practical to leave it as an exact answer, and when would it just be a better judgment to use the rounded. All right. We also have a formula for volume of a cone, and it's actually the same formula for volume of a pyramid. The volume formula is 1/3 capital B times H. And again, capital B means area of the base. So it's not just one single measurement, it's an area, and then height is the true vertical height, not the slant height. So we talked about in class how this is just like area of, or volume of a prism, but it has the 1/3 in there. And so what that means is if you were to put this cone in a cylinder-shaped box, it would actually fit 3 of those cones. It might not look like it, but if you cut up the cone in certain ways, you could fit 3 of them in that cylinder. All right, so the area of the base of a cone, that's a circle. So more specifically, we could say 1/3 pi r squared, and this r is 3, so 1/3 pi 3 squared, times our height, and this is where we want our true height of 7, not our slant height, so 1/3 pi 3 squared times 7. Okay, I'm going to type as much as that I can in my calculator. There's a couple different ways that you could do this. If you wanted, you could just do 3 squared times 7, which is just 9 times 7. And then you can either times 1/3 using the fraction button, or you probably also know that dividing by 3 is the same as timesing by 1/3. So that actually equals 21, just the number parts of that, not including pi. So our exact volume is 21 pi, and the label is cubic yards. And then typing that into the calculator and rounding, 21 times pi is 65.97 approximately cubic yards. Okay, on to the next page. All right, number 7. We have the same directions on this page. We're finding surface area and volume, trying to be as exact as we can. And number 7, you see we have a rectangular prism. So for surface area, we just want to add up all the areas. So how many faces are there? Well, we have a top and a bottom, a right and a left, and a front and a back. And notice that in a rectangular prism, each pair of those that I stated have the same area. So I'm going to organize this kind of in the way that I said, front and back. I'll do that first. You can go in any order. So you can see the front is 14 by 10. So that's just a rectangle, 14 times 10, and then I'm just going to add on times 2. because there are two of them, a front and a back. So 14 times 10 times 2 is 280. All right, how about right and left? If you look at the right and left side, the right side is 9 by 10. So the right and left is 9 times 10 times 2, and that is 180. And then lastly, the top and the bottom. The top and bottom, if you look at the bottom here, you can see it is 14 by 9. So 14 times 9 times 2. That's not the only way that you can calculate it, but in my mind it's the easiest. So that's 252, and then we're just going to add all of those up. So I should probably label what I'm doing here. This is surface area. See, it makes more sense if you show what you're doing. 280 plus 180 plus 252, and we get 712. So the surface area is exactly 712, and that would be square feet. Now, the volume of a prism is the area of the base times the height. There's actually a bunch of different ways you could view the base. I'll just kind of view it as it's standing here, the base being 14 by 9, and the height being 10. So it's really just 14 times 9 times 10, because the area of the base is 14 times 9, and the height is 10. So what's 14 times 9 times 10? It is 1,260. So the volume is 1260 cubic feet. Number 8. We have a pyramid. Now, when you think about the surface area of a pyramid, what is exposed on this pyramid? Well, we have a triangle here, a triangle there, and then we have two triangles that are kind of unseen in the back. And the base is a square. The directions say all polyhedra are regular and or right. So normally we wouldn't assume that it is a square, but with that direction, yeah, we can assume that this is a square. So our overall game plan here is we want to add the square area to the 4 triangles area. Well, if this is 10, then this is 10 also. So the square is 10 by 10. And how about the triangles? Well, if that's 10 and the height of the triangle is 16, then we can do 1/2 10 times 16. And the reason why 16 is the height of the triangle, it's not the height of the whole pyramid. The whole pyramid height would come from here. We'll talk about that in a minute. But it is the height of this slanted part, which is the triangle. So 16 is actually the slant height, L, of the pyramid, but it actually is the height of the triangle because it's perpendicular to this base. If you just view it two-dimensionally, that's what you have. Now, we have 4 triangles, so I'm going to put this 4 times that right in there. So this would be 10 times 10 is 100. And I mean, if you want to do each triangle separately, you could. If you just did this part of it right here, 1/2 10 times 16 is 80. And then we have 4 of those, so that's 320. Add the 100, and our surface area is 420 square feet. Now, the volume of a pyramid is the same formula as volume of a cone. It is 1/3 the area of the base times the height, and that is true height. That's not slant height. That's the distance from the center straight up to the top. And the center means that it comes halfway in the square from one of the sides, and it would form a right angle there. Now the area of the base, we just did that. That's 10 times 10, or 100. The height is the part we don't know yet. We got to figure out. So do you see how that forms a right triangle? It kind of goes through the pyramid, through the middle of the pyramid, and we have a right triangle in there. We know the hypotenuse of this right triangle is 16, and we actually know this bottom part here is 5, because if the whole square is 10, this goes halfway across. I'm going to draw this right triangle that we have with a hypotenuse of 16 and a bottom side of 5. And so then we want to find the true height, h. So we'll set this up according to the Pythagorean theorem. H squared plus 5 squared equals 16 squared, so that's 25 and 256. And if you subtract 25 from 256, you get 231. And if you try and take the square root of 231, it does not come out evenly. In fact, I don't even know if there's a way to split up 231. Well, let's see. We'll explore that. So if we want to simplify 231 here, let's see here. It doesn't divide by 2. It does divide by 3. 3 and 77. Let's see here. 77 divides by 7 and 11, but that's it. So, 3, 7, 11, there are no pairs in there, so basically we are going to leave it as square root 231. If we're going for an exact answer, that would be as exact as we can get it here. So there is your height, square root 231. So if you do the 1/3 times 100, that's 33 and 1/3. I'm going to write 33.3 repeating. Radical 231, and that would be our exact answer for volume. Because I have this repeating sign on there, it means that it keeps going and I'm actually not rounding, and so that would be cubic feet. So it would definitely be wise here to also include an approximate answer where you would round, and if you type that in, you get 506.62. This would possibly be another one where if you didn't give me the exact answer, I'd probably be okay with it, just because it's just not very practical to say 33 and 1/3 radical 231. It's hard to get a sense of how big or small that number is, where 506.62, even though it's rounded and it's not exact, it's more practical. It gives you a better feeling or sense of how many cubic measurements are in there. How many cubes could you fit in there? All right. Number 9, we have a cylinder. So we've actually already done a cylinder before, so on this review. The surface area of a cylinder is 2 pi r squared plus 2 pi r h. And in this case, we know the 4 is the radius and the 9 is the height. We can just see that, so we'll just plug it in. 2 pi 4 squared plus 2 pi 4 9. All right. 2 times 4 squared is 32. So 32 pi. Over here, 2 times 4 times 9 is 72. So 72 pi. And those are like terms. 32 pi's and 72 pi's. You can add those together and you get 104 pi. So 104 pi square centimeters. That is the surface area. And of course we can round that to 326.73 square centimeters. And we've also dealt with the volume of a cylinder on a previous question in this review. It is just pi r squared times h. So that's pi 4 squared times 9. And if you multiply the 4 squared times the 9, you get 144 pi. So that's 144 pi cubic centimeters. And if we round that, it's 452.39. Okay, on to number 10. We have another pyramid. And you can see this is a square pyramid. It's 6 by 6. So the surface area is where we're going to add the square plus the 4 triangles. Well, the square, again, you can see is 6 by 6, 36. Let's talk about the triangles. If we just look at one of the triangles, let's say this one here, it has a base of 6. But do you see how we don't know what the height is of the triangle? That would actually be the slant height for the pyramid. So it's kind of the opposite situation of the last pyramid one that we did. And you see that we do know the true height of the pyramid, but that's not the height of the triangle on the side. That's the height of the three-dimensional pyramid. If we connect these dots here, kind of inside the pyramid, you see we get a right triangle. Let me just draw that right triangle outside here. The height of that right triangle is 4, and since it would go halfway through the bottom square of the base of the pyramid, that would be a distance of 3. So it's a 4 by 3, and we want the slant height L. So Pythagorean theorem, 4 squared plus 3 squared equals L squared. That's 16 plus 9 is 25. Oh, this one works out quite nicely because when we do the square root, it comes out evenly to 5. So if this is 5, then the area of this triangle is 1/2 base times height, 1/2 6 times 5. But we have 4 of them, so I'm going to put 4 times that. So again, if you want to just do one triangle, 1/2 6 times 5 is 15, but since we have 4 of them, that makes an area of 60. Add the original 36 from the square on the bottom, and our surface area is 96 square inches exactly. All right, the volume of a pyramid is 1/3 area of the base times the true height. And so we know the base is 36. We knew the true height is 4. And so we just times 1/3 times 36 times 4. And it works out to 48. 48 cubic inches, meaning you could fit 48 1 by 1 by 1 cubes inside here. All right. Just a few left now. On to the next page. Okay, number 11. This is a triangular prism. Do you see how we could slice into this like a piece of cake and cut a few pieces, actually 5 pieces, that would all look exactly the same? So it's a triangular prism. To find the surface area, we're just going to add up all of the faces. So let me start with the front. You can see it's a right triangle, 6 by 8. And so we just do 1/2 base times height. So 1/2, 8 times 6. But can you also see that the back part is also going to be that same right triangle? So I'm going to make this front, back, and whatever 1/2, 8 times 6 is, I'm just going to times it by 2. So if you multiply all those in, you get 48. All right. We can do a couple others pretty much right away. The bottom part is a rectangle, and it's 8 by 5. So 8 by 5 is 40. The left side is 6 by 5. This 5 that's right here would be the same width that's right here. So 6 times 5 on the left is 30. And so the part that we haven't done is the top, which is a rectangle. It's a slant. It is a rectangle. And we know it's 5 deep, but we don't know how wide it is, so to speak. And so you can see it's part of a right triangle that's 6 by 8. I'll just call this, how about W for width? And if we just do the Pythagorean theorem on that, 6 squared plus 8 squared equals W squared. Well, 6 squared plus 8 squared actually works out to 100. So very convenient. When you take the square root, it comes out evenly to 10. So that means this is 10. And so that rectangle is just 10 by 5. So the top is 10 by 5, which is 50. So add them up. 48 plus 40 plus 30 plus 50, and we get 168. Again, make sure to label the surface area, 168 square yards. volume will actually be a much shorter calculation here. To find the volume, it's kind of like how many times is this base repeated. If you think of the base as the triangle, the area of the triangle is just 1/2 6 times 8, and then we have 5 identical slices we could make of that triangle. So we're going to times it by 5. You know, the first 1/2 6 times 8 equals 24, and so that would be the volume of just one slice. It would be 24 cubic units. But we have 5 slices, so we're going to do 5 times that. So the volume, 1/2 8 times 6, and then we have 5 slices of that. So it's like 24 times 5, which is 120 cubic yards. Number 12. We have a cone. In this cone, we know the radius is 8, and then we know 17 is the slant height. It's not the true height. I know we're going to need to figure out this true height eventually, so I'm just going to do that right now. I don't know if I'll need it right away or not. I got to look up the formulas, but I know I'm going to. So I'm just going to use the Pythagorean theorem. H squared plus 8 squared equals 17 squared. 17 squared is 289. 8 squared is 64. If you subtract those, you get 225. That's very convenient because when you take the square root, it works out evenly to 15. So the true height is 15. Okay, surface area for a right cone is pi r squared plus pi rl. And we know all those values. Pi 8 squared plus pi 8 L is 17. That's one where we actually want the slant height. So that would be 64 pi plus 8 times 17 is 136 pi. Those are like terms. You can add 136 and 64 and it works out to 200 pi. So the surface area is 200 pi square millimeters, or approximately 628.32 square millimeters. Volume of a cone is 1/3 area of the base times the true height. So area of the base is pi r squared because the base is a circle, so pi 8 squared. The true height is 15, not the slant height, that's why it's h. And then we have the 1/3. So I'll do all this that I can without typing in pi. Maybe I'll go backwards. Maybe I'll do 15 times 8 squared. Then you can do times 1/3, or you can just do divided by 3. And it works out to 320. So 320 pi cubic millimeters. And if you multiply that out, you get 1005.31 approximately. 1005.31 cubic millimeters. Alright, last problem here, number 13. It's kind of weird only having a chapter review with only 13 problems, but each one of these is a double problem, in some sense maybe even a quadruple problem because we have exact and approximate for a lot of these. Alright, back to a sphere. Again, you can just use the formulas. The surface area of a sphere is 4 pi r squared. And you can see this 7 actually is the r. So 4 pi 7 squared. If you do 7 squared and 4, you get 196. So the surface area is 196 pi meters squared, or approximately 615.75 meters squared. And the volume is 4/3 pi r to the third. So that's 4/3 pi 7 to the third. I'm going to type that in using the ABC button. 4 ABC3 times 7 to the third, or 7 caret 3. And actually, here's what my calculator says. It says 457 and 1/3, and then there'd be a pi after that. I suppose if you left your answer like that, I would understand what you meant, but usually we don't write a mixed number times something else like that because it's just kind of confusing. Do you mean the 1 times the pi, the 3 times the pi, everything times the pi? It's just kind of like you wouldn't write 5 and 2/7 x. That just looks a little weird. So usually with a sphere is when this happens. And so you're going to either get 1/3 or 2/3, in this case 1/3, so you should probably just know that if you get 457 and 1/3, another way of writing that is 457.3 repeating. I like that a little better because the repeating part is still exact because it keeps on going and going forever, and we know exactly what you mean. We mean 457.3 times pi. The whole thing is times pi, and so that would be cubic millimeters. And if you cubic meters, excuse me, and if you type that in and round, you get 1,436.76 cubic meters. So again, most people kind of like the sphere ones because you can just use the formulas. Alright, that is basically what we studied in Chapter 12. Good luck in your studies.